At this point, we're ready to use the chain rule to return to our study of exponential functions. When we studied exponential functions, we learned that the derivative of e to the x was e to the x. That was a very special case. We had learned that the derivative of any exponential function, b to the x, was going to be some multiple of b to the x. It was just a constant times the original function. And that's because exponential functions have this really powerful property that their rate of change, their derivative, is proportional to the function value. It's just a multiple of the function value. At the time, I had to tell you that the constant of proportionality when the base was e was 1. That was a gift from the mathematicians that have gone before. I told you that I wasn't going to tell you at the time what the constant was for other bases because we would have the tools to figure that out later on, and we do at this point. What we're going to do is we're going to use the fact that e to the x and the natural log of x have a very special relationship, and that's that they're inverse functions. Inverse functions just undo each other. So if I call e to the x f, I could call the natural log of x f inverse. And if I compose inverse functions in either order, they just undo each other. So f of f inverse of x. So that's taking x, plugging it into the log, then plugging that into the exponential function. That undoes what the first function did, and it just gives me x. Same thing with f inverse of f of x. That would be the natural log of e to the x, and that's just x. Now, what we're going to do is we're going to use this, and we're going to apply this identity to b, to the base of our exponential function. So if b is the same thing as e to the natural log of b, that means that b to the x, an exponential function with arbitrary base b, can be rewritten as e to the natural log of b to the x. So I can rewrite it so that its base is e. Now I have a power to a power. So what do I do when I have a power to a power? I would multiply those exponents. So this is e to the natural log of b times x. Do be careful. It's not the natural log of bx. It's the natural log of b, which is just a number, times x. I'm going to use that now to calculate the derivative of b to the x. I'm going to do that by writing it this more complicated way, which is actually a function composition where the inside part is the natural log of b times x. So I'd say, okay, I'm plugging that into the exponential function. The derivative of e to the something is e to the something. What's the something? Natural log of b times x. Times the derivative of the natural log of b times x. So that's going to be e to the natural log of b times x times. Now I've got to figure out what this derivative is. And sometimes you say, oh, but you haven't taught us the natural log yet. But I don't need to know that because I'm not taking the natural log of x. This is the natural log of the natural log of b times x. So let me ask you this. If I had 2x, what's the derivative of 2x? That would be 2, because 2x is just a line of slope 2. If I had negative 5x, the derivative of that would be negative 5, because that's just a line of slope negative 5. If I have natural log of b times x, the derivative is just the natural log of b, because this is a line through the origin whose slope is that constant, the natural log of the base. Cool. Now notice this e to the natural log of b times x, this first factor that I have here, That was just a fancy way of rewriting b to the x. We rewrote it that way so that we'd be able to take the derivative. But now I can just say this is b to the x times the natural log of b. That's a constant. That's my k. Usually in the formula we write that first. So we would say it's the constant natural log of b times the original exponential function b to the x. So it is true that the derivative of an exponential function is a constant multiple of that exponential function. Now we know that that constant is the natural log of the base. That actually works here because the natural log of e is just 1, and that's the constant of proportionality we get when e is the base. But now we know a whole bunch more formulas. I know that the derivative of 2 to the x is just natural log of 2 times 2 to the x. I know that the derivative of 5 to the x is natural log of 5 times 5 to the x. So for any base, that's any positive number other than 1, because we don't count 1 to the x as an exponential function, this is the formula that we will get for the derivative of that exponential function. So now we can add that to the rules we know, and it's kind of neat. We got to this point using the limit definition, but now that we know chain rule, we were actually able to finish it without having to go back to the limit definition of things, just by using this function composition and knowing that the derivative of e to the x is just e to the x.